Welcome Year 12s to this video. Hopefully it won't be too long. The purpose of this video is for you to skip ahead to any questions that you have, say, made a few mistakes on in this assignment, or you're still not sure what those mistakes were, or you weren't sure, in fact, how to answer the question at all. So I've made this video. I'm going to go through each of the questions. Some of them I'll do quite quickly because they weren't really a problem at all, but some of them I will go through really slowly because what that means is quite a few students have actually answered those ones incorrectly. Before I start, I do want to apologise. When I photocopied this particular sheet, it's come out on a little bit of an angle, so don't adjust your screens or anything. It's not you. It's my sheet that's actually on a tiny bit of an angle at the moment, so I do apologise. Okay, so like I said, if the first few questions aren't applicable to you, do just skip ahead. I am going to go through this in order. So question 1, you were given 2 variables. So here we have retail sales and we have season. So this particular display, as you can see, is a bar chart, but the bar charts that we've been looking at tend to have frequency along the vertical axis. This one's a little bit different, but the point of the question is to get you to look at the variables and decide whether they are categorical or numerical. So this question was answered really well. Most of you could see that the season is a categorical variable, so it's giving us a quality, not a quantity, whereas retail sales is clearly numerical. And remember, the question to ask yourself is, does it make sense to calculate the average? So for retail sales, yes, it does make sense to calculate an average retail sales. So it is numerical data. For the next one here, we were given again 2 different variables, and this time we were asked which would be the best display. Now the reason a histogram would be the best display is, first, look at the piece of data that you've got, the variable that you've got, and decide, is it categorical or is it numerical to begin with? Because some of these are for categorical data and some are for numerical. So ATAR score, does it make sense to calculate an average ATAR? Yes, it does. So ATAR is numerical. So for that reason, I'm going to eliminate a few because bar chart, that's for categorical data. So it's not going to be bar chart. Segmented bar chart as well is for categorical data. So I'm not going to use that one. The last 3 here they are for numerical data, but there's a few things that you need to ask yourself. First of all, would it make sense for me to put ATAR scores? And keep in mind, you've got 45 of them. Sorry about that, Java's wanting to update. You've got 45 values here. So we don't really want to use a dot plot, A, because you're going to have 45 dots, not really practical, but B, those 45 dots, if you think about ATAR score, you've actually got quite a range. You've actually got continuous data. You could have ATAR of 80.00, 80.05, 80.10, 80.15, etc. So you could, in fact, have 45 unique values. So if you think about that on a dot plot, that's not really going to work. You could potentially have no dots stacked on top of each other. And you could also have a really, really massive range because you could have data, say, below 20. You can have an ATAR score below 20 in your particular distribution. You could have all the way up to 99.95 effectively. So it's just not practical to put this on a dot plot for so many different ways. A back-to-back stem plot would have the same issues. The range will be too large, and I mean the uniqueness of the data, that's not a problem. In terms of the stem, it could work really well because you could have, say, all your scores from, I might just draw a little picture. You might be able to say scores in the 50s, scores in the 60s. But if you think about that, in fact, because you've got decimal points, that's not going to work either. So if I go back, you're going to have in your stem 50. And then from there, actually thinking about it's not even going to work at all. And also, if you have a look at this back-to-back stem plot, that actually means that you've got the stem in the middle and you've got 2 sections either side. Now that's just not going to be, there's no reason for that. You've got one variable here. You don't have two when you're looking at just ATAR score. So we're left, of course, with a histogram. And what that would allow us to do is probably group the data. So you would have, say, ATARs of 50 to 60 in one column, 60 to 70 in the next, or to less than 70, and so forth, so forth. So that would be the best. So something like that for your histogram. Remember, with the bars touching. For the variable distance, that is, again, ask yourself, does it make sense to calculate the average? Yes, it does. So it's numerical, and distance is a measured variable as well. So you're going to have any value across a huge range potentially. So it is continuous. For the next one here, key thing is to see it's less than 3 people living in the house. So I'm thinking of all of these ones here, which there are 5 of them. Now we are asked for a percentage, so you need to know how many there are altogether. So you need to count them up. So we've got 5 there, another 5 here, we've got 10. So 5 out of 10 times by 100 is half of them, so 50%. For the next one, this one was reasonably well done, but just be careful because this value, now I'll show you what the key mistake is with this one. So you should have got C. We wanted the percentage that participate in a lot of exercise. So you're looking at this one here, which you'll see is on the top. So it's drawn on the top in the key. It's on the top in the columns as well. Key mistake is to say, okay, this is about 56. So they look at this bit and look at the scale and just read off what that one is. And so this one, they might go, oh, that's 76. Of course, that's incorrect because we want to know how much of this column is in that color or is shaded as so. So really what you want to do is if you are going to do it that way, you need to go 100 minus the 56 or 100 minus the 76, and you should get your 44 and 24, and then of course you need to find the correct one in the list. With these ones, so we want the number of students who weigh more than 32. You want to find 32, which is here, and we want more than that, so everything to the right. Sometimes I think it's good to just jot down what the frequency is at the top. So we've got 10, 5, 4, and 2, and then it's a case of just adding them up or totaling them, and we get 21. We wanted next the percentage who weigh between 26 and 30. So same strategy, find your 26, find 30, and we want everything in between there. So I've got 3 and I've got 6. So I've got 9 of them, but I want this as a percentage. So 9 out of 42. Now it does say in here that there are 42 of them. So I don't need to go ahead and tally all of them up. Of course, if you're not told however many there are, that is what you need to do. So 9 over 42 by 100 to get it into a percentage. This one here, we've got a histogram. Have a look, your tail is down here. And if this was a number line, that would be the negative end. This would be the positive end. So we have a negative skew. If there was a data value, say, that was isolated, that was quite extremely low compared to the rest or extremely high compared to the rest, then I would say yeah, potentially there's an outlier, and we tend to use that word possible outlier. So this one I just say negatively skewed. These ones, whilst they are unusual compared to the rest of the data, because it sort of, I guess, gradually lowers the columns, I guess I'm saying, as it gradually drops off, you don't have one that is isolated compared to the rest. So I wouldn't say that there is an outlier in that particular set, in that distribution. Well, this is quite on an angle, I do apologise again. We are again looking at a histogram. We want the percentage who failed the test, and we're told that the pass mark was 50. So here's the test scores, there's 50 there. So again, I just need to tally up to begin with. So I've got about, looks like 4. This is discrete data, so it should be exactly. So you're talking about the number of students. So I've got 4, 3, 2, 1 and 1. So you've got 11 out of the 50. So that's 22%. Now this one I'm going to skip over only because we needed probably to give you a little bit more information in this particular question. So the class sizes of 5 further maths classes were recorded. So if I just make up some data now, just say you had a class that was 20, 22, 22, 23, and say 24. So that's our data there. We've got only 5 pieces of data. It's probably not really, well, it's numerical data here, so that's categorical there. That's categorical as well. Dot plots, I say for this question is the most, or it's the best for this particular one. First of all, we've got a very small data set. Really small, only 5 values. Probably not going to go to all the trouble to have a histogram. And a stem plot as well. Whilst you can use a stem plot, it's not too bad. A dot plot's really good for those very small data sets. So something like this is okay. So like so. Moving on now to number 11. This question here, there were quite a few errors with this one, so I just want to let you know, first of all, the number of students in the class, you're not told. So do what I've done here, put a number at the top of each column, and then we're just going to add them all up because that will give us the total frequency. Frequency's on the side here. So you should get 24. The number of students with marks 60 and above, well, I would go to 60, of course. There it is there. And I would tally however many are to the right. So 7 plus 5 plus 2. So we've clearly got 14. Now this one, the centre of the distribution. This probably is the most poorly answered question. When we're talking about the centre of the distribution with a histogram, we are of course talking about the median. Now we've had a bit more practice with this since the Smart Start week. So hopefully when you've had a look at this, it makes a little bit more sense. First of all, we work out how many data values there are. There are 24. So then we do our n plus 1 over 2 to work out the position. Remember, it's the position only of the median. So when you do that, you get 12.5. So I'm going to go up here, back to this, and I'm going to count, well, I'm going to start adding up the frequencies. I'm going to go from this side because it's going to be easy. I'm going to get to the 12th value faster if I go from the right. So 2 and 7 is 9, 9 and 5 is 14. So that's actually taken me over my 12.5. What that means is that 12.5, or between the 12th and the 13th, is going to be in that column. If I go from this side, 1, 2, 3, 6, 7, 8, 9, 10, and again, I'm going to get over the 12th and 13th in this column. This column is between 60 and 70, or 60 and less than 70 really, but if we go down, it's a little bit slow, it's in that particular interval. And that's what we have to do with a histogram, is we don't know exactly what the value is. We only know where roughly it's located. Okay, so the log questions. These ones I'll go a little bit slower because these were, on the whole, probably the most poorly answered on the whole test. So obviously we need a little bit more practice with logs. So this question, let's pick it apart so we know what it's asking. We've got maximum speeds and they're on a log scale. So what this means is we've got say 1, 0, 1, 2. We could have it in the negatives, of course. I'm just doing this for the moment. And we've got log of the speeds, the maximum speeds. Okay. We then, of course, have columns above that because this would be on a histogram. It says that just there. And we've got that 30% of cars of a maximum speed are greater than the number 2.15 on the log scale. So that's going to be around here. So 30% were above that, but we want to know, what does that number there, 2.15, what does that represent in its actual speed? So it says, what speed does this represent? So at the moment, it's as a log. At the moment, the log of the max speed is equal to 2.15. So what this is asking me for is what value, when you take the log of that value, gives you 2.15. And there's two ways to do this. First of all, easiest way, the one I think most of you will prefer, will be to use solve. So in your calculator, you would type menu 3.1 to start off with. You then press on the log button. It'll come up with a little box down here. Just skip over that because it'll always be 10 and your calculator will default to that. In max speed, where max speed is there, I'm just going to type in X because of course you're not going to type in max speed. That's just for me to show you what I'm doing. And that's equal to 2.15, comma, X. So we're solving for X. And you'll see it comes out as 141.25. The other way is the log value itself is giving you whatever we raise the number 10 to, whatever power we put on that number 10 to give us 2.15. So if I actually go 10 to the power, I'll say that again. What this log is doing is it's saying what number, when we raise 10 to the power of 2.15, will give us this one, the max speed. And I probably just confused even further. So if you don't like what I'm doing here, just use solve for me because there's nothing wrong with doing it that way. So if I've got log 10, what this is saying is 10 to the power of this number will give me the maximum speed. And you'll get 141.25. I'm going to do this way again when I do number 16. So I'll come back to that in a second. All right, so the next one. Here we have number of cars owned per capita for 70 countries. And we've got a log display there. Here it is, log 10, number of cars owned. So we've got 70 countries altogether. So that's important because I'm going to use that. Now we want the percentage where number of cars owned is more than 1. Okay, so this is saying just one car owned. So this is just cars owned. This is just the original value. Original, not the log. What we need to do to be able to, I guess, interpret this histogram here is we're going to have to know what is the log of 1. We need to know how would one car being owned as a log, what would that look like on this scale? So your first step will be to convert to the log. So log 10 of 1. Now that's going to be equal to 0. Why is that? And that's because 10 to the power of 0 equals 1. So like I was doing before, 10 to the power of this number will be equal to that one there. Just take those arrows off for a second. So we get a log value of 0. So then I look up here, I find 0. So that's log of 1. And I count how many are to the right of that because it's saying we want how many are more than this value. So if we have a look on the scale here, it's going up in ones. So this is 1, 2, 3. I have 3 of them out of 70. That's how many there were in total by 100 to get a percentage. That is closest to 4%, therefore C. And the last one here, another log 1. Now we want the modal income. So first of all, I recognize the mode is the most frequent. Here we go. And in this case, it is the interval. It's asked for the modal interval or the modal income, whereabouts it would be. So what range would it be? And it's going to be in here. So that's not an income of 4 or an income of 5 because clearly we're working with a log scale here. So what I need to do is this value here, that's log of the income, which is equal to 4. And the one next to it, that one there, is log of the income, equal to 5. So again, what you can do is you can use solve here and solve for income, or just call it I, or just call it X. And what you're going to get is 10,000. You do the same with the other side of the interval, the upper end, and you're going to get 100,000. Now you're doing it the other way. So remember, this is 10 and this is 10 here. I want to know this value here. It's going to be 10 to the power of 4 is equal to what's in the bracket there. 10 to the power of 5 is what's equal to the bracket here. So sometimes these little arrows went a bit far there. So 10 to the power of this number equals that one in there. So sometimes you'll see me do it this way. If you're wondering what I'm doing, that's because I'm working with a log base 10, and that's how logs are working. They're actually giving me whatever power to raise to a 10 to get this number here in the bracket. So we should get C when you evaluate that. Okay, so moving on to the short answer section. A lot of this was done really, really well. Some people wrote the answer down here rather than filling in the gap. Please follow the instructions always. You were asked to complete the table, so you needed 8 and you needed 40 to 44 in this section here. You'll see on the side here I've just got mark allocation. So if you're wondering what everything was worth, I just went with half a mark for each of these. Number of cars that waited the lights for less than 25 seconds. Well, I need to find that here. So that's 25 is here. So less than 25 would be everything above that. So 3, 5, 7, 10, 11. 11 cars. Percentage that waited 40 seconds or more. So find your 40, add them up. There's 5 of them. And there were 39 altogether. You can see that in the total. So 5 on 39 by 100. The next one was not answered very well. So again, it's the median interval. First of all, there are 39 values. So we do n plus 1 on 2, and we get the 20th value. Start from any end. Doesn't matter which end you start from. But what I'm going to do is add these up as I go until I get to the 20th value. So 1 and 3. So 4, 6, 8, 11, 17. And you'll see in the next one, I'm going to go over 20. So it's going to happen in that 30 to 34 second interval. All right, the histogram. Just a few notes about this one. First of all, I was looking for labels on both axes. So frequency needed to be on the vertical axis. And this is cut off a little bit, but it should say time spent waiting. And it's really important that you put the unit. If you just put time spent waiting, that can be in hours, that can be in months, that can be in years. You must always mention the unit. Some people lost marks because they said minutes when it did clearly say up here, whereabouts is it? There, seconds. So do pay attention to the units. Okay. So histogram, no gaps between the columns. I was looking for a scale like this one, so using the same intervals that were given to you. So some people wrote their intervals like this. They wrote 0 to less than 5. That's okay as well, but it can get really, really squishy. So I recommend doing it like this, so like I've done just here. Some people had the values in the middle of the column. Now with continuous data like, or with intervals like we have here, we shouldn't have the number in the middle. When it's discrete, and so just say I've got a table up here and I've got just 0. So there were, say, 1 person that waited 0 seconds and 3 people that waited 1 second, etc. Then labels in the middle are okay. But when you're working with intervals like we are here, the labels should be either side of the column. When you've got no data, you don't skip on the scale, you leave it there. It's just going to have a frequency of 0. So some people, again, just just precision is what I'm after. So some people skipped columns, some people the frequency was incorrect. There was lots of different errors here, and precision, attention to detail, using a ruler. Please don't come into an assessment without a ruler, especially when you need to construct histograms, dot plots, stem plots, box plots. You need a ruler. You will lose marks if your work is not accurate. Okay, the shape of the distribution, it's clearly it's got a negative skew, so it's got a tail down here, a lot of data up this end, and there's a possible outlier because this one here is a fair bit isolated from the rest of them. So do mention this word possible. You know that now that we've done our box plots as well, that there is a way of determining whether an outlier is actually an outlier. We can't do that with this data here because we don't have the actual value, so you wouldn't be asked to find the upper and lower fences. So do use this word possible to demonstrate you haven't calculated whether it's an outlier. You just think it might be just by looking at it. This last one here, again, another histogram. Do jot down the numbers on top of each column and then you just need to tally them. The reason I say that is lots of people got this number wrong and we really don't want to be doing that. Those questions there, ladies, are the easier questions that I want everybody to be getting right. So have some sort of strategy. The ages were approximately symmetrical. If you ignore that little possible outlier there, this is reasonably symmetrical. So I would say that symmetrical with a possible outlier. Now I recognize you didn't get a lot of space here. Now the center is in this interval 40 to less than 50. So if we know there are 44 of them, we go 44 plus 1 over 2, so 22.5. And again, you need to start from one end, so we're going to get 9, 17, 29. That's taken me over the 22.5, and so I'm in this interval 40 to 50. Now when you do this, remember the 50 actually belongs to the next column, so you should be using this little symbol here, 40 to less than 50, or 40 to 50 but not including 50 is another way of saying it. So you'll see that I've drawn that in on a lot of the answers I got here just said 40 to 50. So please make sure you're using that less than symbol. It doesn't actually include 50. 50 belongs to the very next interval. The spread is approximately 90 years. So how do I do that? 100 is the maximum value that's present here on the histogram. The minimum is 10. 100 minus the 10. And the last one, the possible outlier. Again, my only point I want to make is can you please make sure you put that less than symbol in. Okay, if you do need any extra assistance with these questions, you need to let me know. You can do that via an email, or you can arrange to meet me at say a recess or a lunch, or alternatively ask me in class. There's often times that you can pop your hand up, you can say, look, I've got a few questions and I'm more than happy to answer them, okay? But it is up to you to let me know, because at times, obviously, I'm not going to be able to read your mind. I need to know these things if you are still struggling, okay? So thank you very much, ladies, and I will be seeing you for our first little test. Remember, it's not a SAC. Our first little test, which is happening next week. So thanks for listening.